Start.
Good morning, Ronald present here. I am going to take subject of structural analysis 2. So first topic, we need to study about the basic concepts. So why are we analyzing the beam? Because of the load condition, different load are acted on the beam. So on that condition, we have to analyze the structure due to some bending acts on the beam with different conditions. So first, in structural analysis 1, we have studied more about the determinate beam structures and indeterminate beam structures. So we have to carry the moments and shear force by using the shear force and bending moment diagram. So first, we have to know about the bending moment. Why we separate the beams by determinate and indeterminate beams. So first, in determinate beams are nothing but we have solved the equations by summation of horizontal forces and summation of vertical forces and moment. These three equations are equilibrium equations. So based upon that, we solve the problems and find the moment, bending moment. In indeterminate beams, these three cases are not sufficient to calculate the bending moment. So first, we classify the determinate beams and indeterminate beams. Determinate beams examples are cantilever beams and simply supported beams. Indeterminate beams are examples continuous beams, overhanged beams, and fixed beams. So first we start with fixed beams. So based on the load conditions, UDL so in this beam, fixed beam, UDL load is acted on this beam. So we have to find fixed end moments. On these beams, we have to derive the equations by using these general equations. Horizontal forces equal to 0, vertical forces equal to 0, and moment is equal to 0. By using these three equations, we cannot find the bending moment or shear force. So based upon this, we have to create or add new equations to this beam to solve bending moment. So we have A and B support. In these supports, we have to calculate the moment about AB. So we have a formula of minus WL by 8 for this is for to calculate the moment at A and moment at B. So next step, we have to move on to the next beam, continuous beam. What is continuous beam means? There are two or more supports. So A, B and C. In these continuous beams, various loads are acted. Point load UDL. So we separate these continuous beams by two spans, A and B, span A and B. And span BC. We separate these two beams and we calculate the bending moment diagram or bending moment equations to solve the continuous beam. So first, span AB, to find out this bending moment diagram or shear force diagram, we separate this A, B and BC. So for span AB, there is a formula for point load centrally acted.
Okay.